good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Picard. And today we're getting into Unit 4. It's actually Video 1, Graphing Quadratic Functions, the wonderful world of quadratics. Our learning targets, you can graph quadratic functions using the y-intercept, vertex, and axis of symmetry. And you can find and interpret the maximum and minimum values of a quadratic function in real-world problems. So let's jump right into it. First of all, we have this problem. Rock music managers handle publicity and other business issues for the artists they manage. One group's manager has found that based on the past concerts, the predicted income for a performance is a quadratic function right here. P, or profit, P of x equals negative 50x squared plus 4000x minus 7500. This is a quadratic equation because of the x squared. As soon as you have an x squared in your problem or your function, it's no longer a linear function, it's a quadratic function. And the shape of that graph is right here. We call this a parabola. It's like an upside down U, or kind of a close to a V, but not really. What happens to the income as the ticket prices rises? Well, you can see down here we have the ticket prices and the income in thousands. So let's say right here the price of the ticket is $10. They're going to roughly make almost about $30,000 if they sell tickets for $10 a piece. If they raise it to $20, well, they're going to make more money. They're going to make about a little over $50,000. All the way up to this top point right here. That's the maximum point. That is also called the vertex. The point that is the top point of a parabola is called your vertex. If your parabola opens up, then that point, the vertex, would be the bottom point of your parabola. So parabolas open up and down. Anyway, after the price of a ticket is $40, and when it goes to like 50 and 60, we'll say, then the price starts to go down. And the reason is less tickets are going to be sold because of the price of the ticket is a little more expensive. Maybe people can't afford it or just don't want to pay that much for a ticket. So there is something to be said about finding that maximum price of a ticket. In this case, it would be $40. Okay, so graphing quadratic functions. This is a quadratic function. One thing, the key is there's an x squared term. Also, look at the number in front of x squared. That's negative 50. That means my parabola opens down. If it would have been positive 50 here, then our parabola would have opened up something like this. So, quadratic function equations in the form of f of x equals ax squared plus bx plus c. The key is we have an x squared. It's a quadratic function. The a in front of that x squared tells you whether the parabola opens up or down. If a is positive, it opens up, just like we see right here. If a is negative, it would open down. A couple things. Your y-intercept is when x is equal to 0. For example, f of x. If you plug in 0 for x, that'd be 0 squared plus b times 0 plus c. These would cancel out. 0 squared is 0. 0 times anything is 0. So if you plug in 0 for x, you're going to get your y-intercept. So your y-intercept is always this c term. That's where it would cross the y-axis. Axis of symmetry. All parabolas have what we call an axis of symmetry going up and down here in red. Any point on one side, you can flip over the axis of symmetry. Let's say this is 2 points away, or 3 units. I'm sorry, 1, 2, 3 units away from axis of symmetry. I go 1, 2, 3 units past it to get the point on the other side. But your axis of symmetry, there is a formula for it. This is just a vertical line, x equals whatever constant it is, of negative b all over 2a. You can find your axis of symmetry. Also, your vertex then, your x coordinate of your vertex is negative b all over 2a. And whatever this is, you have to plug that number in for x, evaluate it, and you can find your y. So this is kind of a big formula. We're going to be using this formula over and over again to get our parabola started. Usually when you graph a parabola, you graph the axis of symmetry. It isn't really part of the parabola, but it is that line where you flip points across from it. I talked before about this. If a is positive, f of x equals ax squared, plus bx plus c. If a is positive, your graph is going to open up like this. And your vertex will then be a minimum instead of a maximum. If you have a negative a, x squared, plus bx plus c, it's going to open down. If that number in front of x squared, the coefficient of x squared is negative, it's going to open down like this, and you'd have a maximum value. Okay, so we're going to graph one. We're going to find the y-intercept, vertex, and axis symmetry. One thing I'm going to add to this is you're going to make a little table whenever you're graphing these parabolas. Sometimes you don't have to, but a lot of times you do. And first thing you're going to find, well, our y-intercept. We know what our y-intercept is. If you plug 0 in for x, these would cancel out and you're going to get 3. So 0, 3, or 3 is my y-intercept. I know it's going to cross right there. So I know there's 1 point on my parabola. But what I like to find first is the axis of symmetry. And that's where we get into that little formula. X equals negative b, or the opposite of b, all over 2a. Well, b in this case, here's a. A is actually, if there's nothing in front of it, it's just 1. So this is a, this is b, and c is 3 right there. A, b, and c in our quadratic function. So negative b, I take the opposite of whatever b is. So if b is negative 6, I'd put a positive 6 right there. All over 2 times a, and if there's nothing in front of x squared, that's just 1. So this is 6 over 2, or x equals 3. This is my, I'll call it AOS, axis of symmetry. It splits our graph of our parabola right in half. And we're going to graph that first. I'll put it in green right here. X equals 3. So count over on the x-axis, 1, 2, 3, and it's just a vertical line through x equals 3. And that's my AOS. And that just stands for axis of symmetry. So right here I'd put x equals 3. It's a line. It's not just a point, it's a line. But that gives me one thing. That gives me the x value of my vertex. I'll put vertex right here. I know that 3 is going to be the x value of my vertex. To find the y, I'm going to plug 3 in for x right here and evaluate it. So I'm going to find, now this g of x is the same thing as y, so I'm just going to write y equals, first of all, plug in the 3 in, 3 squared minus 6 times 3 plus 3. This is 9 minus 18 plus 3. 9 minus 18 is negative 9. Negative 9 plus 3 is negative 6. So my vertex is 3, negative 6. Okay, so let's graph that vertex. I'll graph it in 3, then down 1, 2, 3, 4, 5, right there. There's my vertex. So, axis of symmetry is right here, this green line going up and down. I have my vertex. Any other points that I have, I can flip over the axis of symmetry, like my y-intercept here. It's 1, 2, 3 units away, so I'm going to go 1, 2, 3 units past it. I have 2 points. I could actually graph my parabola right now. But what I want you to get used to is start with your vertex, 3, negative 6, and either work your way up or down to 0. 2, 1, 0. I know when I plug in 0, I get 3. We already figured that out. That's my y-intercept. I'm going to plug in 2 and 1 now so you can kind of see how this graph opens up. I think you should make this table every time. It's going to help us, especially in 4.2 when we start finding solutions for these graphs. So I am going to plug in 2. I'm going to y equals this 2 right here. 2 squared minus 6 times 2 plus 3. That's 4 minus 12 plus 3. 4 minus 12 is negative 8. Negative 8 plus 3 is negative 5. So 2, negative 5 is another point on my parabola. So count over 2. Down 1, 2, 3, 4, 5. Now, I have an equal and opposite point on the other side that's 1 unit away, so I go 1 unit past it. There it is. So every time you graph a point on a parabola, you can flip it and find another point on the other side of that axis of symmetry. Last but not least, I'm going to plug in this 1 right here. So that's 1 squared minus 6 times 1 plus 3. So 1 minus 6 plus 3. 1 minus 6 is negative 5. Negative 5 and 3 is 2. So 1, 2. I'm sorry. One plus, it's not 2. 1 minus 6 is negative 4, or negative 5. Negative 5 plus 3 is negative 2. Sorry about that. So over 1, down 1, 2 right there. This is 2 units away from my axis of symmetry, so I go 2 units past it, and there it is. That's enough points to definitely graph. You can just kind of rough it in there. A parabola. This point right here, being it opens up, is a minimum. The minimum is your vertex. In this case, it's 3, negative 6. So if you want to know where the minimum occurred, it occurred at x equals 3. What is your minimum? The actual distance down is negative 6. And that's graphing a parabola. Let's try another one here. Okay. You should be able to tell me what my y-intercept is right away. If I plugged in 0 for x, I would get, these would cancel out and I'd be left with 2, so my y-intercept is 2. We can graph that in if we want right away, or you can wait, either or. And we got to get that axis of symmetry, AOS. X equals, what's the formula? Yes, negative b all over 2a, using that over and over again to graph your parabolas. Opposite of b, okay, here's a, here's b, and here's c. b is negative 8. Opposite of b would be positive 8, all over 2 times 4. So this is basically 8 over 8, or 1. What does that mean? It means my axis of symmetry is x equals 1. I'll graph it in red this time. So count over on the x-axis 1, and then just draw a vertical line right through that bad boy. AOS, axis of symmetry, is x equals 1. So all our points, we're going to flip over that. I want you to make a table, get used to making a table. That's going to help you out when you want to find solutions and such. We're not going to do that till tomorrow, but first thing I got to do is find my vertex. Well, I know half of my vertex right now. And we found the x value, and that is this 1 here. It's the axis of symmetry. Well, our vertex lies on the axis of symmetry, so the x value is the same, which is 1. So, to find the y value over here, you got to plug that 1 in for x and solve. Once again, f of x is the same thing as y. Y equals 4 times 1 squared minus 8 times 1 plus 2. Okay. So 4 times 1, well, it's 4, minus 8 plus 2, 4 minus 8 plus 2. That's negative 4 plus 2. I'm going to get negative 2. So 1, negative 2. First point, 1, negative 2. Work your way to 0. 0, I usually want to graph at least 3 points. I'll probably plug in negative 1, 2 also. So 1, negative 2 is this point right here. I know when I plug in 0, that's my y-intercept. And that's 2. So I can flip that point over the axis of symmetry. It's 1 unit away here, so I go 1 unit past it. I think when I plug in negative 1, we'll plug in negative 1 here. That's going to make this a positive 8. This is still going to be 4. What do I end up with? Negative 1 squared is 1. 1 times 4 is 4. Negative 8 times negative 1 is positive 8. And the 2, so that's 12 plus 2, that's 14. Negative 1, 14 is going to be way up here somewhere. I'm not really sure where it is, but it's off the chart. So I'm just going to graph it in with the points that I have. You can see that it opens up. There we go. There's our parabola. Once again, this point is a minimum. You can see right here that our A is positive, so our graph is going to open up. If it was negative, it would open down, so you got to be aware of that. I didn't plug in the vertex here. It was 1, -2. And there it is. That's our parabola. That's what you guys are going to practice. We're going to work on that in 4.1 and 4.2. Now to some application problems. There's a lot of different applications with these problems. An object is fired straight up from the top of a 200-foot tower with an initial velocity or at a velocity of 80 feet per second. The height, h of t, of the object, t seconds, so our time, t, is in seconds, after firing is given by this function right here. I'll write it again. H of t equals -16t squared plus 80t plus 200. They give us this 200-foot tower. That's the initial height. Your constant is always your initial height, so that 200 is in there. The initial velocity is always going to be your b, and you can see they put the 80 in there for us. What does the -16 represent in front of the t squared? That's gravity. It's pulling it down. So yes, this shoots it up, and yes, we start at a height of 200 feet, but because of the t squared, eventually that -16 will take over. It goes up for a while, and then it'll come down. Anytime you shoot something in the air or throw something in the air, the shape of it is a parabola. Here's our little tower. That's great. Let me get rid of that for right now. I'm going to draw us a little picture here. So here's our tower. It's 200 feet. A ball goes up, and eventually gravity takes over, and it comes down and hits the ground, and it bounces. But the main thing is this shape is a parabola. It says find the maximum height reached by the object. Well, the maximum height is always going to be your vertex. So basically, we just have to find the vertex of this function over here. Axis of symmetry would go right through something like that. That's negative b all over 2a, and it's also the x value of our vertex. So first thing we gotta do is this. X equals negative b all over 2a. So opposite of 80 is negative 80 all over 2 times -16. So negative 80 divided by negative 32. And I'm pretty sure that goes in there 2.5 times. Now, I said x, but we're not working with x anymore, we're working with t. So this is actually the same thing as my t, or my time. So at 2.5 seconds, basically I'm asking, what is the height of this building? Well, that's going to be part of our vertex. 2.5 is our time. Now we need the h of t, or the height. How do we find that? Plug 2.5 in. For t, or what would be x in a normal function, and evaluate it. H of t, well, I'm just going to put h here for height, equals -16 times 2.5 squared plus 80 times 2.5, and then finally plus the 200. I think that ends this. Squaring this and multiply it by -16, that's -100. Plus 80 times 2.5 is 200, plus another 200. To me, that's 400 plus the -100. It reaches a maximum height of 300 feet. So you found the time, 2.5 seconds, and the maximum height that it did reach is 300 feet. 300 feet above the ground. So vertexes, you can use those when you're working with quadratic functions. Here it's quadratic because of the t squared. You can use that to find maximum height using the vertex. The first number that you're going to find, the x, or in this case the t, the time, is 2.5 seconds. You plug that in to find the maximum height. Okay, Libby throws a ball in the air with a velocity of 64 feet per second. She releases the ball 5 feet above the ground, so she's probably about 5 feet tall, that's what it's saying. The height of the ball above the ground, t seconds after release, is modeled by the function, here it is, h of t. H is height, t is the time again. -16t squared. This negative 16 right here, that represents gravity, the pull, plus a v sub 0 t. V sub 0 is your initial velocity. Well, they told us they were throwing it, where is it? The initial velocity right here, 64 feet per second, so that's 64 t. And plus h sub 0 right here, that's your initial height. Well, she's about 5 feet tall, so when she throws it, the ball is released at about 5 feet. So, we'll say, I'm not very good at drawing stick figures. This is Libby. She throws the ball up in the air and it comes down. We are looking for, I think, it says find the maximum height the ball reaches. Once again, it's not a typical parabola, but actually it is a typical parabola. It's just a little bit wider, I guess you'd say. We're looking for this vertex. When does it reach that maximum height? We plug the time in for t, and then we can find the maximum height. So once again, we're looking for a vertex. So that's basically t, h of t. We need to find t first. And you do that by, it's usually x equals negative b all over 2a, but we're going to say t equals negative b all over 2a. So negative 64 all over 2 times a is negative 16. So it's negative 64 all over negative 32. That equals 2. So what does that mean? At 2 seconds, it reached its maximum height. So if I want to find the actual height, the actual maximum height, I got to take and plug in 2 for t and evaluate this function. So I'll just call it h. Well, you can say h of 2 if you want to. Equals negative 16 times 2 squared minus 64, no, sorry, plus 64 times 2 plus the 5. If you square that out, evaluate it out, what do we get? Negative 16 times 4 plus 128 plus 5. I think the grand total is 69 feet. So the maximum height, which is what they're asking for, is 69 feet. And that's all she wrote. So I want you guys to try some of these. We'll be doing this some more tomorrow in video 4 too. I'm going to show you some different things there also. But that's it. Peace out, Girl Scout.